Hey guys, welcome back. In the last lesson, we saw the need for RCFile, what is RCFile, and what is the structure of RCFile. In this lesson, we'll see how to create and use RC files. One of the contributors to the RCFile project when it was created was Facebook, and Facebook used Hive extensively. RCFile from the very beginning was designed to work and integrate well with Hive. Even though RCFile can be used with Hive, Pig, and other similar tools, you will see it predominantly used with Hive. In this lesson, we will not only see how to use RCFile with Hive, we will also see how to use RCFile with Pig. You can create a RCFile from scratch by writing a Java program using the RCFile Java libraries. But in real world, you will already have your dataset in another format, and that gets converted into an RC file. The data that gets end up in HDFS comes from a variety of sources, and it is most likely coming in as more traditional formats, such as a text file with some kind of delimited values. It is not likely the dataset is coming in as RC file, which means the dataset needs to be converted into a RC file. Let's see how we can convert our stocks dataset, which is a text file with comma delimited values, into a RC file. You can write a Java program to read the text file, and using the RCFile Java libraries to create and write to a RC file, that is just time consuming and totally unnecessary, because there is a better way and it can be achieved without writing a single line of Java code using Hive. I'm logged into the Hive shell. Let's go into the stocks_db database. So I'm going to say use stocks_db. Now I'm going to do a describe formatted command on the stocks table. So I'll say describe formatted stocks. Here we have a regular Hive table named stocks. This is the same table that we used in our Hive lessons, and this table is referring to our stocks dataset in HDFS, which is a text file. And here is the location of that dataset. So let's copy this location, and I'm going to do a Hadoop fs-ls on this location. And here is our dataset. The dataset is about 428 MB in size, and it is a text file. Our goal now is to convert this text file into a RC file. If you look at the description of the stocks table, you can see that the table's input and output format is text input format and text output format respectively, which means this table is designed to handle text dataset. We're going to create a table which can read and write RC files named stocks_rc, which means the text input format and text output format should be replaced by RC file input format and RC file output format, which are designed to read and write RC files. Once the table is created, we will select all the records from the regular stocks table and insert it into the stocks_rc table. And here is a create table instruction to create stocks_rc table. The last few lines are very important. First, you would have to provide the SERD for the table. Here we will provide columnar SERD, which is designed to handle RC files. Next, we'll specify input and output format, and we'll use RC file input format and RC file output format. Since the output format of the stocks_rc table is RC file output format, when you attempt to insert anything into the stocks_rc table, the data will automatically stored in RC file format. Pretty simple, right? Let's now create the stocks_rc table. Let's copy this instruction. I'm going to switch the database to another database named file_formats. I'm going to say use file_formats. Now let's paste the create instruction. There you go. Hit enter. Stocks_rc table is now created. It is now time to load or insert data into the table. We will select all the records from the stocks table and insert it into the stocks_rc table. During the insert operation, the output format that we specified in the stocks_rc table will be used to store the files. Since the output format is specified as RC file output format, the text data from the stocks table will be inserted into the stocks_rc table, will be converted and stored as RC file. Let's go ahead and execute this insert statement. Enter. This will kick off a map-only map-reduced job, so let's wait for the execution to complete. There we go. The data is now loaded into the stocks_RC table. Let's do a simple select, limiting the number of records to 100. So I'm going to say select star from stocks_RC limit 100. We're able to query the stocks_RC table, and we're able to see the data as well. Let's make sure the data behind the stocks_RC table is in fact stored in RCFile format. So let's run a describe formatted command on the stocks_RC table. So let's say describe formatted stocks_RC. Here is the location of the data set behind the stocks_RC table. Let's do a HDFS directory listing on this location. So let's copy the location. Let's do hadoop fs-ls, paste the location. There were two mappers used in the map-only map-reduce job during the insert operation, so we see two files here. So let's pick a file, and let's do a hadoop fs-cat to see the contents of the file. Hadoop fs-cat, paste the location. The RC file is stored in binary format, and it will not be in a human-readable format. And that is exactly what we see here, confirming it is a RC file. So we're able to convert a text file into a RC file with just a simple insert statement. Let's now compare the size of the regular text file with RC file. So let me clear the screen. Let's do a directory listing where the text file is stored. Let's now do a directory listing where the RC file is stored. The stocks dataset in text format is about 428 MB. And the same stocks dataset stored in RC format is stored in two files, and the combined size of these two files is about 364 MB. That is a 64 MB reduction in size. Pretty good compression, right? The size benefits on bigger datasets will be very apparent with RC files. Now, let's go back to the Hive shell. Let's run a simple aggregation query on our newly created stocks_RC table to make sure everything looks good. Here's the query to compute average volume across all records in the stocks_RC table with symbol B7J. So let's copy this query and execute. Here is the result. It took about 24 seconds to calculate the volume for all records in our stocks dataset stored in RC file format with symbol B7J. We have already compared the size of RC file and a non-RC file. In our example, we have seen a 64 MB reduction in size with RC file. Now, why don't we run the same query on our regular stocks table, which is in text format, and compare the execution times? Keep in mind, we're working against a small data set on a 3-node cluster, so we can't perform any meaningful performance comparisons. But let's just compare the execution times anyway to see whether we see any improvements to the execution time. So here's a query to calculate the average volume from our regular stocks table for symbol B7J. Copy and execute. Here with the non-RC file, we get the execution time a little over 26 seconds, which is about 2 seconds slower than our RC file execution. Again, keep in mind, we are working against a smaller data set and on a 3-node cluster. So this is not a very accurate and scientific performance comparison. But with bigger data sets and on a bigger cluster, the performance improvements will be very visible and significant. One of the main reasons behind RC files performance is lazy decompression. When we execute queries with predicate, or in simple terms, queries with filter conditions, RC file does not scan the entire row group. It first decompresses the column inside the row group in question and check whether any of the column value matches the value in the filter condition. If there is a match, then the other columns in the row groups are decompressed. If there is no match, RCFile will skip the row group and move on to the next row group. Since RCFile has the ability to skip chunks of data, you can easily understand why queries with filter conditions will be faster with RCFile. Any column-specific operations or queries with aggregation, etc. will benefit from the column store implementation in RCFile. The beauty here is the queries you write are exactly the same between RCFile and a non-RCFile format. RCFile takes care of optimizing the executions behind the scenes for you. If you have a data set which fits a table structure, consider converting that to a RC file for better performance. Oh, by the way, RC file is certainly a good start, but ORC file format, which is an optimized version of RC file format, performs better than RC file, which we'll see in the next upcoming lesson. Now we know how to read and write RC file using Hive. Read operation is demonstrated by a simple select statement, and write is demonstrated by inserting data into table, thereby creating the RC file. Let's perform similar operations with Pig. With Pig, let's first see how to read an existing RC file. Do we have an existing RC file? Of course we do, right? The data behind the stocks_RC table is a RC file. So we're going to use that file for this demonstration with Pig. Before we can write Pig instructions to work with RC file, we need to register two jar files. One is the piggy bank jar file because it has methods to load and store RC file. And the next jar file is hive-serde, which has supporting libraries for storing the files in RC file. So I'm going to copy these two instructions. Let's enter the pig's grunt shell. Let's register both the jars. The load instruction to load the data which is stored in RC file in Pig is straightforward. The important thing that we should note here is the load function we are using. We will use Hive columnar loader function to load data stored in RC file format. The location that you see in this instruction is the location from the Hive stocks_RC table. Once the data is loaded, you can work with the data just like you're working with any other file format. In the next instruction, we're projecting three columns: exchange, symbol, volume. Then we are grouping all the records by symbol. Finally, we are calculating the average volume by symbol, and we limit the number of records to 10. Let's go ahead and execute these instructions. Let's copy these instructions, and let's execute. Finally, let's execute the dump instruction on top 10 to display the top 10 records on the screen. And there we go. We see the results. Everything is working as expected, and this also confirms that we can work with RC files in Pig. We just saw how to load an RC file in Pig and how to work with RC file. How about if we would like to store the data into a RC file in Pig? Let's say we would like to store the output of top 10, that is the output that we saw on the screen, into a RC file. We'll use the Hive columnar storage store function to store the data into a RC file. Let's copy this instruction, go back to our cluster, and execute. And there you go. The execution is now complete, and we have successfully saved the output of top 10 into an RC file. So let's go to the location where we saved the RC file and try to open the RC file to make sure it is in fact saved as RC file. So I'm going to do a Hadoop fs-ls, paste the location. Now I'm going to do a Hadoop fs-cat to open this file right here. You can also see this file has a file extension .rc, indicating it is an RC file. So let's execute. As expected, the file is in binary format, confirming it is a RC file. So to summarize, in this lesson, we looked at how to work with RC files with both Pig and Hive. It is pretty straightforward, correct? We also compared the size and execution times between an RC file and a non-RC file. And we are able to see the improvements. With that, let's wrap this lesson. See you in the next lesson.